Caroline Alk, also from the Department of Education and Training. I just was wondering about that scenario, the CSIRO scenario that you put up at the end, because are you arguing that that is actually a feasible scenario, or are you just putting it up for the... I mean, what are the assumptions behind that? Because I would have thought a lot of people might question how realistic it is to assume that carbon capture and storage technology is going to work, is going to have that massive effect, is going to be able to be rolled out, etc., etc. But are you actually making a claim that you think it is all feasible, it's all quite doable, and it's just a matter of political will?
No, researchers never make claims like that because we're always after more research dollars. One of the great beauties of scenarios is that you're not claiming anything. You put in a set of assumptions and you look to see what comes out of it. And this particular modelling had a whole range of different scenarios that came out with different things. These numbers come out of techno-economic modelling with certain constraints in there. So it's saying, with the set of assumptions behind this scenario, this is what the mix turned out to be. There's no claim that this is the right mix, and indeed we need to do, I would argue, we need to sort out priorities and then keep developing technology in all the plausible scenarios right up until we know that they're cost effective and feasible, or they're not. It's a point I tried to make at the beginning is the future is very uncertain. It's not like it's all laid out and we just go and do it now.
We now move on to our second speaker, Dr. Alan Lowe, who worked at the Electricity Commission of New South Wales, subsequently Pacific Power, from 1968 to 2003, where he held senior positions in power plant design, technology development, and boiler and environmental control plant performance for a range of different groups. He completed a PhD on radiation heat transfer at the University of Newcastle and subsequently became involved in a number of UNDP overseas training programs, lecturing in developing countries in Asia on coal utilization and pollution control, with a view to assisting these countries improve their coal utilization technologies and practices. Dr. Lowe was part of the team that made a successful application to form the Cooperative Research Centre for black coal utilization and served as Program Manager, Technology Assessment with the CRC from its inception. Since leaving Pacific Power in 2000, he has provided advice to the power industry on coal technology and plant performance issues and completed the study of geosequestration, looking at the options for New South Wales. Dr. Lowe presently holds positions of Adjunct Associate Professor with the Engineering Faculty at Sydney University, lecturing on energy and its impact on the environment, and he's also the Chief Technologist with the Cooperative Research Centre for Coal in Sustainable Development. Thank you very much.
Clearly from my background you'll see that I'm a fossil fuel person, and I'm going to perhaps talk about one of the wedges, one of the Socolow wedges, which will allow us to reduce our carbon emissions into the future. Before I do that, I want to put this into a bit of perspective. I know we're talking about Australia's energy security, but I think we need to step back a little. I'm going to, I hope, answer some of the questions that have just come out. So let's see how we go here, so we can get this thing to work. Firstly, just a few thoughts on energy security, and this is, I guess, a big picture view. It's not energy security for Australia or for me or you, it's the world in general. Firstly, there's an interesting little law called White's Law, which states that culture equals energy times technology. White was an anthropologist, and he studied a lot of societies over many hundreds of years. Sorry, societies going back over hundreds of years. He didn't do that over hundreds of years himself, of course. And he came to this little rule. If you want to reduce your energy use, but maintain the level of culture, which is your level of advancement, then you have to increase the level of technology. Conversely, if you reduce your energy, maintain the same level of technology, the level of culture that you have decreases. There's no hard and fast rule behind that particular law, but if you look at what happens around the world today, you find an excellent correlation between energy use and quality of life, such as the indicated by the Human Development Indicator provided by UNDP. So we need energy, no doubt about it. If we want security, we have to have equity of energy, and this is perhaps something that people overlook. Presently around the world there's about 2.5 billion people who rely for their energy on wood and cow dung, and that's simply not equitable. That has to be addressed. Society is becoming globalised. We can't look at security on behalf of ourselves alone. It's a global issue, has to be solved by global issues. And finally, we tend to think over short terms, really. We need to think in terms of plus 50, plus 100-year timeframes. And that's what the IPCC, the International Panel on Climate Change, is looking at. They're looking at those sort of timeframes. Currently, we use about 11 billion tonnes of oil equivalent, and we're producing about 7 gigatons of carbon. I've written it as CO2, but it's actually gigatons of carbon. That's just a lot of carbon. Just remember the 7. We'll come back to that. 80% roughly of the world's energy comes from coal, oil and gas, and there's about 0.5% from what Dr. Reynolds called the new renewables: solar, wind, heat and geothermal. It's a trivial amount. This work was done leading up to one of the first IPCC, International Panel on Climate Change reports on global CO2 emissions. It looked at whether we would basically run out of air or run out of carbon. The question is, do we have a problem with emissions or do we have a problem with supplies? It tries to work out the cost of supply of carbon, gigatons of carbon across the bottom, and it recognises all those reserves I talked about, and it looks at what would happen for somebody, or what would appear for somebody at 2100, looking back to see what we've got in the way of fossil fuels and how much it cost us to get them. In other words, it's allowing an improvement in technology over time. Improvement is 1% per year, not a lot, but it actually allows for that. The numbers, you could argue about the numbers here, I have to say, but the order of magnitude you can't. We've got 5,000 gigatons of carbon locked up as fossil fuels that we expect to get for something like $40 a tonne. It won't necessarily be very convenient fuel. It might be anthracite, which is pretty hard to use, or it might be coal tar, which is equally as unpleasant, or high sulphur, but it's there, it can be got. This looks at some carbon emission trajectories projected by the IPCC, and they're looking at how we might conceivably get to 550 ppm of CO2 in the atmosphere. That's a little bit higher than we currently are now, but it's seen to be a number that may be sustainable. It shows a band of different scenarios of how we can get to there. The scenarios, again, I'm afraid, time going out across the bottom axis and gigatons of carbon emission going up the top. We're currently around there. There's a gigatons of carbon equivalent, which is, sorry, I won't go into that. It's a little bit more than the emission from from fossil fuels. If we don't do anything, we go up a trajectory like that. If we take some actions, we're going to have to turn it around. If we're out here at 2100, if I can see correctly, we have to be about half of what we're currently doing if we want to get down and maintain that 550 ppm in the longer term out here, which is where organics come into it. Why carbon capture and storage? There's a good reason. Firstly, it builds on 100 years of technology innovation. We continue to use our existing investment in infrastructure, skills and capability, manufacturing capability. We don't have to restructure society right now. We can do it a little later. It buys time for development of more cost-effective renewable technologies, and it's applicable on a large scale. It's got a lot of things going for it.